Okay, third lesson of the unit. This time we're talking about a different kind of series. Like the arithmetic series, we're still going to add the numbers in the terms. Add the terms of the sequence together. That's what I need to say. We're going to add those together yet. The difference is this time they're geometric, which should tell you something about how you find each term, meaning we're going to multiply each term by a value to get to the next value. So it's not the same as the arithmetic because we're not getting the terms the same way. So let's take a look at a couple of problems here. Here I'm supposed to evaluate each geometric series described. The first one says I'm going to take 4 and subtract 20 and add 100 and minus 500, and I'm going to do that until I got 7 terms. Now, what I could do is like the very first arithmetic series that we had is I could get every one of the 7 terms and just go ahead and add. Not bad if I only have 7 terms. What about that second one over there, though? It says a sub 1 is negative 4. A sub n is a negative 26,244, and r happens to be 3. I don't know how many terms are in that. I really don't want to have to find all that many of them because this is going to be kind of large. So how can we figure these out? What we want to do is, like we did on the arithmetic series, is we want to find a formula that's going to help. So let's look at an email problem. So here's my email. Oops. Here's my email problem. Suppose you email a joke to 3 friends on Monday. Each of those friends sends a joke on to 3 people of their friends on Tuesday. Each of those persons sends a joke on from Tuesday to 3 more people on Wednesday, and so on and so on and so on and so on. So how many people have seen this joke after 8 days? Would be the question. So to help us figure out that question, we need to develop a formula for the sum of a geometric series. So consider this situation. What I could do is I could actually figure out what is each of those values for every single one of those 8 days that I'm talking about. Okay? Now, I can start with that sequence. It's only 8 days, so not too bad. I can figure that out. Now, what I want to do is I want to take that sequence of numbers, that series of numbers, and I wanted to try to make it as easy as possible. When we did the arithmetic sequence, we just flipped everything around. This time, let's multiply the series by, well, let me think this through, by what the common ratio is. What if I took and multiplied every term by 3, since I was sending each person was getting 3 and 3 and 3 and 3 and 3. So if I do that, I get this sequence. I get 3, 9, 27, 81. Notice I shifted it a little because I want these things to line up together. I want the 3s and the 9s and the 27s all to match up. Now, what we did when we were doing the arithmetic, we added those. This time, for kicks and giggles, let's subtract them. So if I subtract them, I've got that. The 1 has nothing to subtract from it. The 3's canceled, the 9's canceled, the 27's canceled, 81's canceled. But the 65, 61 is being subtracted from nothing, so to speak. Now, what do I do over here with the S of 8s? Well, I have actually written, I have 1 S of 8 up there, and I got to take away 3 S of 8s down here. So instead of saying 1 minus 3 is a negative 2, I'm just going to call it 1 minus 3 on there. So now, what can I do to figure out my answer? Well, I can clean up this whole top row just to be 1 minus 65, 61, and then I would divide it by the 1 minus 3, right? I would take the 1 minus 65, 61 and divide it by the 1 minus 3, and that would give me my sum real easy. Now, the thing I want you to notice is you'll see what I got here. The 1 was the first term in our series. I think that's the one I want. Yep. I got to change the size of this little square here. There's something in there. We don't want to look at it yet. Okay, there we go. The 6561 is the last term of our series multiplied by the common ratio. So this is really our 8th term, a sub 8, times 3. So it's really the 9th term. Something to consider there. So whatever the last term is, multiply by that. And then on the bottom, we have the common ratio is at 3. So now if I clean this up, I get this handy-dandy little answer of 3280. Now, what does this mean, this 1 minus 6561 over 1 minus 3? Well, if we look at it very carefully once again, it's telling us that we have a sub 1, which is our first term, a sub 1 times r to the 8th power, and that's what we're talking about right here, the last term of the series multiplied by the common ratio. So I could call this a sub 8 times r, or I could say it's a sub 1 times r to the 8th, all over 1 minus r. This way might be a little easier to look at. Okay? Now, if I continue on with this idea, there I have a formula to figure out the 8th term. Now, what I could do is I could substitute that 8 with an n, and I would have it. And if I do that, I end up with these two formulas. I've got the one where I have it. I want this for my pencil. Okay. So this is basically what we just figured out up here. I replace the 8 with an n. So I have that nice handy-dandy formula. But since both of the terms in the numerator have an a sub 1, I could factor it out and write it like this. Now notice that is 1 minus r to the nth power in parentheses over 1 minus r. The r's don't cancel, the 1's don't cancel. We can't cancel them off. I have to do that subtraction part first. Okay, so there's our methodology. So we have the formula. So here we have our deal. And if we use that formula we just saw, s sub n equals a sub 1 minus a sub 1 times r to the n over 1 minus r. There's our formula. Let's go ahead and use that formula. I know my sum to the 7th term is going to be my first term, 4, minus 4 times, well, what's my common ratio? How can I go from 4 to negative 20? Or from negative 20 to positive 100? That's multiplying by a negative 5. My common ratio is a negative 5. And then I want that raised to the 7th power. And then I divide this by 1 over 1 minus a negative 5. So now if I do this, handy dandy little mathematics, I get 4 mine, it's going to be a plus because that's a 7th. Well, I'm going to have to do that. Negative 5 to the 7th power. So using the calculator is what I'm going to have to do. So 4 minus 4 times, parenthesis, negative 5, close my parenthesis, raise it to the 7th power. I'm just putting that whole numerator into my calculator. And it says I got 312,504. On the bottom, I got 1 minus a negative 5, which is actually 6. So I take my top number divided by 6, and I find that my sum is 52,084. So if I had used all those numbers, I would have got 52,084. Okay, so now let's look at this other problem here. I have the first term, the last term, and r to the 3rd. Recall that this last term right here is really just a sub n. Times 3. Hold on. Skip, let me rethink. Okay, thinking's done. This is a sub n times r. So I could change that problem to say that the s sub n is the first term minus the last term times the common ratio over 1 minus the common ratio. Okay, so in this case, my s sub whatever, I don't know what it is, I'm just leave it as n, is a negative 4 minus a negative 26 to 44 times the common ratio of 3 over, oh, I'm using the wrong marker. S sub n equals negative 4 minus a negative 26 to 44 times 3 over 1 minus 3. So I want to get the top number first. When I get that top number, I get 78728. Divide that by negative 2, and I get a negative 39,364. So when I start talking geometrics, I could get negative values. Same happens with arithmetic. I could get negative values. So let's look at a couple other type of problems here. What if we had these problems? How would you work them? Pause the video right now, see if you can do it. Did you pause the video? Boom. The magic of film editing. So I went through and I worked every one of these problems. So for this problem here in the top left, let me get my magic pen. So for this problem, I used the A1 minus AN times the R over 1 minus R. And I ended up with 59,048. For this problem over here, since they told me the N in the first term and the R, pardon me, took an answer. Here we go. So I did first term times R to the nth power, and I ended up with a negative 1,364. So now let's look at this last problem. Again, remember the big sigma notation, this big sigma notation right here, that thing just means sum of. So that means I'm just going to take the 1 and put it in for the k, and the 2 for the k, and the 3 for the k, all the way up until I get done doing the 9th for the k. So I really have 4 times 3 to the 0 and 4 times 3 to the 1 and on and on and on all the way up, which really means when I look at it, I have 4 plus 12 plus 36 and all the way up to whatever that last number is. I didn't want to figure it out. So what I knew is that I had the first term and I had the R, so I could go ahead and work it just using first term minus first term times R to the n over 1 minus R. I just used that formula once again because the number on top of the segment is how many terms you have. Okay, so that's how we find the sums. Now, how do we find the number of terms? Determine the number of the terms n in each. So I have a first term, I have an R, and I have a sum. I have this handy-dandy little sum thing that I got to find it. Or I have my sigma notation. How do I do these problems when I don't know how many terms I have? This requires just a little bit of tweaking, let's say, but not a whole lot. Okay, so I know my first term. I'm going to go back to this little thing here. I know my first term. I know it's my first term times the common ratio to the nth power all over 1 minus the common ratio. So let's go ahead and use that all the way through every one of these problems and figure it out. My sum is 1,036. My first term is 4 minus 4 times 6 to some power equal over 1 minus 4. So now if I work through this, I get 1,036 equals 4 minus 4 times 6 to the nth power over a negative 3. So what I want to do is get rid of that negative 3. So I will multiply this side by negative 3 and the other side by negative 3. And when I do that, I get a negative 3,108 equaling 4 minus 4 times 6 to the nth power. Now, I get my calculator and I say, what do I do from here? Well, I got to get rid of the first 4, so I'm going to subtract off of 4. So a negative 3,112 equals a negative 4 times 6 to the nth power. And now I'm going to get rid of that 4 by dividing by a negative 4. So I get 3,112 negative divided by 4 negative. I get 778 is 6 to some power. So I could try to figure this out, and that's probably going to be the best way to do it. I'm just going to have to try to guess some numbers. I know it's not 2. I know it's not 3. Is it 4? Is 6 to the 4th power 778? Pause. Unpause. I made a mistake. I fixed it. It's in green. Up here, notice I had written 1 minus r, but I put a 1 minus 4, which was the first term, not the 6. So I should have said 1 minus 6, 1 minus 6 is a negative 5, so I'd multiply both sides by negative 5. I get a negative 5184 equaling that, so then I would subtract my 4, and I get a negative 5188 equals that. So then I would divide by that negative 4, and I would get 1296 equals 6 to the nth power. The reason I knew I had made a mistake is because 6 to the third power was 216. And if I multiply that by 6 again, I didn't get a 700 number. I got this number. So my n has to be 4. Okay, what I'd like you to do is try those two problems, pause the video, try those two problems, see what you get. I will come back in and I'll show you what I got for answers. So now that you've paused the video, you worked through the problems, let's see how I did them. Again, I love this idea that I can just make the videos up and everything's already done. So let's flip down here to the bottom of the page. I did both problems. I used the same S of n formula, a sub 1 minus a sub 1 r to the nth power over 1 minus r. I plugged in the numbers. I subtracted on the bottom. I multiplied both sides by that value. I forgot to put that in here, didn't I? I forgot to say that I multiplied by 3 and I multiplied by 3. Got me the 387 equals. So I subtracted off the 3 in front. Then I divided by the negative 3 in front of the something to the power. Then I had to figure out 2 to what power got me up to the 128th. I knew it had to be an odd number because the 2 is negative and the 128th is negative. I'm only going to get odd on that case if both things, if there's an odd number of negatives. So the n had to be a negative number. I knew n to the 5th was 32, so I went ahead and tried n to the 7th, and it worked when n was 7. So a negative 2 to the 7th got me to the negative 128. It was good. Kind of guess and check. Later on in the year, we'll figure out a shortcut for figuring that out. Okay, so now on the other problem, the 18662 was my sum. What I automatically knew is the 2, because when I put a 1 in for the 6th part here, I get a 6 to the 0, which is a 1. So the 2 was my A1, and that's how I figured it out. And it also told me that the 6 was my R value. So I went ahead and plugged that in. The 2 minus the 2 to the 6 to the nth power over 1 minus 6. I got the negative 5 on the bottom. I multiplied both sides by the negative 5. I subtract that 2 out in front. I divided by the negative 2 in front of the 6 quantity. And I got 46656 equals 6 to the nth power. And up above, we found out that 6 to the 4th power was 1296. So I tried a 6 to the 5th power. It didn't get me up to 46. So I tried another one, and it got me up there. So n had to be 6. So that's how you do those problems. They are a little bit more tricky than, say, the simple arithmetic ones. As long as you can remember, once again, this handy-dandy little formula right here in the middle, those formulas right there are going to be your key to these geometric series. You're ready to do the next assignment. Again, it's online in Google Classroom. Look for the Sequence and Series Lesson 3 assignment, and that's the one you're good to go on.